Alright, so today we're going to extend our idea that we were talking about last class for finding probabilities under the standard normal distribution, and we're going to extend that to any normal distribution. So the idea is essentially the same as what we were talking about last time. So if you have some random variable x that's normally distributed, and it doesn't matter what the mean or standard deviation of it is, then you can find the probability that x will fall into some given interval by calculating the area under the normal curve for that interval. So the idea is still the same. Area is still equal to probability. So in this case, the area to the left of 600 is equal to the probability that x is less than 600 for a normal distribution with a mean of 500 and a standard deviation of 100. So the idea of how we're going to figure this out is we're essentially going to pick up this normal distribution and we're going to lay it down onto the normal distribution that we do have areas for, so that we don't have to try to reduplicate math that's already been done. So essentially all we're going to do is we're going to add one more step to this, and that step's something we've already talked about before. So to find the area under any normal distribution, what we're going to do is we're going to convert it to the standard normal distribution. So remember, the standard normal distribution is just the z distribution. And so to convert from any normal distribution x to the z distribution, we're just going to use our z-score formula. So remember, z is equal to x minus mu divided by sigma, or z is equal to the data value minus the mean divided by the standard deviation. So in this case, if we're trying to find the probability that x is less than 600, then we're just going to convert that to the z-score by using 600 minus 500 divided by 100. Which is our data value minus our mean divided by our standard deviation. And when we do that, we end up with a z-score of 1. So then the probability that x is less than 600 is going to be the exact same as the probability that z is less than 1, which then we know how to find. We can go and look that up on our standard normal table. The areas underneath the normal distribution are going to be the same. So let's look at an example of this. So a survey indicates that people use their cellular phones an average of 1.5 years before they buy a new one. The standard deviation is 1/4 of a year. So a cell phone user is selected at random. Let's find the probability that the user will use their current phone for less than 1 year before they buy a new one, assuming that the variable x is normally distributed. So the idea behind this is the same process that we did before. So the first thing you want to do is you want to sketch this normal distribution out. So I draw out some normal random variable x, and I know my mean is 1.5 years. I know the standard deviation is 1/4 of a year. And so in this case, I'm trying to find the probability that the user will use their phone less than 1 year. So probability that my random variable x is less than 1. So I need to put 1 on here. So just using what I know, 1's probably going to be somewhere about here. And then I want to sketch in that area to the left, since that's what I'm trying to find in this case, area to the left. So that's the area I'm trying to find, is everything to the left of 1. So to find probability that x is less than 1, what I need to do is convert this into a z-score. Now, you can do that calculation off to the side, but I like to write it inside my probability notation, just so that I'm not losing anything and I'm being explicitly clear in showing everything. So probability x is less than 1, that's going to be the same thing as z is less than something. And anytime I change the variable's name, so anytime I'm changing from one distribution to the other, there's going to be some kind of calculation. So in this case, we know that's going to be our z-score calculation. So the probability x is less than 1 is the probability that z is less than 1, which is our data value, minus 1.5, which is our mean, divided by our standard deviation of 0.25, or the 1/4 of a year. And so we do that calculation, and then we get the probability that z is less than negative 2. Now, again, you don't have to show that z-score calculation inside the probability notation. If you don't want to, you can do it off to the side somewhere. But I recommend showing it inside the probability notation so that you don't lose anything. But either way, we get to the point that the probability that x is less than 1 is the exact same as the probability that z is less than negative 2. Now this we know how to find. We did this in the last section. So we just go to our table, since this is an area to the left of a value. We go to our z-score table and we look up negative 2.00. So negative 2.0 is our ones and tenths digit. 0.00 is our 100ths digit. And we just go across until that row and that column meet. In this case, at 0.0228. So the probability that x is less than 1, which is the same as the probability that z is less than negative 2, is 0.0228.